Okay, so far we have a sequence class that looks like this in Scala 2, looks like this in Scala 3. And what I want to do now is try to use this in a for loop. So let me make a few changes here. One thing I want to do is end that class right there so we could start to get used to seeing that as being the end of that class. And then down here, I want to create a main method so we can test this. And I'll just call this sequence test, and it'll be like that. And what I want to do down here is start to use that in a for expression. So I want to create something like val xs equals a sequence, and we'll make that 1, 2, 2, 3, 4, and 5 like that. And now I want to say this. So I want to say for x in x of s do, and just something simple here. So that will be like a print line of x. And that's all I want to do right there. So I've scooped that up. That's first line of our main method. And then this is the block of code here that I want to run. And let me save that and then come down here. We'll get out of the REPL that I was using in the last video. Scoot that up there. And now I want to come back and I should be able to do that right there. And you can see that when I try to do this, I'm getting an error message right here. So it says value for each is not a member of sequence event. So what that means is I'm trying to use x of s inside of this for expression right here. And it is saying, actually, that message probably isn't super helpful. All you can tell is that it's not a member of sequence of int. It is technically a value for each, but it's actually a method. You need to define a for each method inside of sequence to get this to work in a for loop. That would be a little bit more of a helpful message right there. And if I come back here, you can say that we had the same error message back then. And what I want to do now is just come up to here and say, well, I want to define a for each method. And if you think about how for each works based on a past experience, you can tell. And actually, I could just show a little example down here and say, when you call a for each method on a collection like this, you're going to write it like this. So it'll say for every X in that for each, go ahead and do a print line on that X. So what happens right here is I probably should use an IDE. It wouldn't be jumping around all the time like this. But anyway, right here, what happens is this code right here is an anonymous function or a function literal that we're passing in right there. And we're saying for every X, do this. So X can be the generic type that it is here, A. But if you imagine that this is int, you're saying, well, I want to print every integer. So this is an anonymous function and its type would be int to unit, and that's because println returns unit. I want to say that I'm going over this quickly because I assume that you've seen this in the other courses, and I'm just doing this as a refresher. But again, if x of s contained ints, this would be an anonymous function that transforms an int into the unit type here because println returns the unit type. So that's what's going on there. And therefore, when we define for each, we're going to say, well, I want to be able to take an anonymous function up here. And I could call that f for a function that we're going to take in. And then it's going to transform, as I just mentioned, the type A into the type unit. That's the way for each works. Even though I just show println here, that's the way for each works in every use case, is that it transforms something into the unit data type. It's always used for side effects like this. And then as a result of that, it returns the unit type when it's finished. And then if I was defining my own sequence structure here, I would do something with that. But the way I'm going to do this is I'm going to cheat and just use the elms for each method here. And again, that's because I don't care about how I implement the body. I just want to show you how to create these functions, basically. And again, in a future video, I'm going to show how to write a linked list class. And in that case, we will implement this entire body the correct way. But for right now, I'm just saying I want to do it this way, like that. And so now if I save that, oops, I need to clean that code up down there. But now if I save that, we see the compiler error messages go away. So what I was trying to show is that if you want to write code like this, which is a for loop, not a for expression, then you would implement a for each method with the proper type signature right here. And then the error message that you see here goes away as soon as I implement this method properly or with the proper type signature. And now what I want to do is instead of compiling, let's go ahead and run this application. And all we have to do for that is that. And we see the correct output from our for loop. So earlier I was just showing that it was compiling correctly. And now I'm showing that our for loop right here is running properly and printing out 1 through 5 just like that. So far, so good. We have implemented code that works just like I'm showing in the book over here. So let's go ahead and move on to our next step.